Welcome each and all of you. My name is Dziomdziora and I will present today you the automatic disease detection with the use of artificial intelligence, machine learning and deep learning with the cloud computing. So why am I here? Because for the 3 years I'm already the internal technology trainer, and also for the 3 years are pursued for my PhD studies from telecommunication and computer science. And actually this project appeared from both combining the IT sector from my PhD studies and collaborating with the Cyber Poland, now of course Knowit Poland company. Okay, so today we will touch the topics from the group of the good health and well-being sustainable development sector, which is goal number 3. And we will touch the areas like the issues of artificial intelligence, the high-level concept of machine learning. We will speak a little bit about the deep learning, cloud computing, data description, and finally I will present you the results which I obtained from the research methodology. But of course this is entry-level session, so there will be no fancy equation or stuff like that. I will just give you the firing talk so you can go to your homes and try similar stuff on your own. Okay, so first things first. What is the artificial intelligence? This is the very big group of the different sectors of mathematics, logistics, knowledge, which combine each other to somehow determine the rules which allows us to predict some measurements, to predict some data. And also nowadays we know that those are separate IT departments which start to focus on artificial intelligence indeed. So why they are focused on it, why the new sectors appear, why the clients nowadays seek the AI in the technologies? Because more and more problems are not efficiently algorithmizable. What does it mean? So for example, today one of the sessions was about the flood level detection. So there is no mathematical equation, will the flood appear or not? Or we can, for example, imagine the runner who wished to complete the marathon. Will he get injured or not? Those are the questions which we are not able to answer in the simple approach. That's why we try to build the system which will allow us to interpret somehow existing data. What are other areas when we can speak about AI? So entire set of logistic problems like the transportation, of course logic games like chess, like Go, which was like 5 years ago finally fully algorithmized, and algorithm battled the best player in the world. Also mathematical theorems proving and all kind of real life translation, text, images, stuff like that. Okay, but let's go deeper into that. So when we think about more modern and more fancy applications, one of that can be using fuzzy logic to determine in the big companies either our machines operate accordingly or not. So for example, we record the sounds which our device is generating, we analyze it over the time, and before real symptoms appear, through analyzing AI data, we can determine, okay, there's a possibility that in the next month probably something will fail. So hey, system administrator, go over it and check it already so we can save money. Okay, now I will show you some fancy stuff about the AI. Because yesterday in Poland it was National Day of Independence. I want you to meet the Jan Sebastian Bach, which is a famous musician, and over his songs there is a Google Doodle which allows you to play with his songs and try to create your very own random music which Google's fits to real Jan Sebastian Bach sound. How does it work? So I will put some random notes. I have zero knowledge about the music. I will click harmonize. And what is Google doing? He's going through all the notes of 306 Johann Sebastian Bach sounds. He's analyzing the rhythm, tempo, and he's trying to add the missing notes so it will sound like real classical music. It will take a few seconds, and in a moment I hope we will be able, if my internet connection is not broken, to hear the boosted music. If not, I will just give you the link so you can play it home. Okay, never mind. Let's leave it. Is it? No. Another very powerful and also dangerous stuff. A lot of you have social media like Facebook, Instagram, or whatever, and we can hear nowadays the dangers of fake news. How does it look in the real life? So the scientists generated the OpenAI tool, which is already forbidden because they figure out how dangerous it is. So it used to work like that the user types one real sounding sentence and AI generates all the fake description, which is so convenient that we cannot determine which part was written by a human and which is not. And here is a kind of very frustrating example, because we say about the UK economy, we know about the Brexit and stuff, and we just start the sentence with one random number, and this AI gives all the, you know, almost like facts sounding sentences, which can be easily distributed through the world. So we also must be aware that this is a very powerful tool. However, in the same time, this is very easy to make harm of it. So always when you develop anything AI related, you must think about the end users, not to harm them anyway. Okay, so we started with the big picture of the artificial intelligence. Now let's go deeper. So what is machine learning? This is a subset. So we started with the big circle. Now we go deeper to the smaller circle. And the difference is machine learning precisely it's part of the knowledge when we try to learn, to make our program learning somehow. So he can get new data which we never saw, like the new float levels, new images, and say, is it a cat or not? And those make it somehow intelligent. Why we need it? Because most of our problems usually need some kind of intelligence, some kind of thinking, because all the simple tasks were already covered by the various of regular tasks. So you can download Excel, Word, to-do list, and it's very simple. However, if you, for example, want to have an app which tells you how to change your daily habits so you can have more energy, it is more fancy because it needs to analyze your routine, when you go to sleep, when you eat, what you need, and finally it will give you a recommendation. Okay, most probably the third coffee should be before 3 p.m. so your level of hormones is better, and then you will get the deeper sleep. And that kind of problems and programs are not possible without the machine learning approach. And on the end of it, let's say the candle of the piece of the cake is the deep learning. So the most complex, most elaborate, the smallest subset of entire artificial intelligence knowledge, because in the deep learning, we already, let's say, lose control what is happening. So in machine learning, step by step, we say, okay, take this data, use that algorithm, and this field exactly describes what I want to achieve. And deep learning is something like, okay, I will give you data, you do whatever you want, and give me the output. So let's take a look how it goes on the image classification. So on the top, we can see the regular machine learning approach. So first we take an image, then we say, dear machine learning algorithm, this area marked on the red is the face of my example human. Please learn how to determine it. And we use some mathematical equations to describe, okay, that probably the eyes are on the same level. Usually humans have the same distance from the left eye to the right eye, and things like that, then from the available algorithm, for example, from the Python sclearn or the Azure machine learning for .NET, we choose like the decision trees or sector vision machine algorithm, and finally we train manually, we test manually, and we got the output. However, deep learning is much more fun because we just say, hey, this is the image, I want to determine similar to it, and deep learning under the hood creates many hidden layers, so it tries to take all the possible factors. So it divides this image, for example, to 100,000 possible features, which we even are not possible to describe in the words. He tries to combine everything with everything and tries the best possible way. Okay, I think I know how to find the human faces. And usually the results of deep learning are much higher than the machine learning algorithm. That's why nowadays more and more fancy problems I addressed only in the deep learning. For example, in any games, when we have artificial trained bots, or the players in, for example, Counter-Strike, usually under the hood there is the deep learning which analyzes the behavior of the player and tries to adjust dynamically to make it counteraction. Okay, so as a developer or anyone who is trying to deal with the data scientist, what do I need to do to begin the machine learning? First, I must define the problem. Okay, what I wish to resolve. For example, I don't know, I want to determine either as a runner of the marathon, will I get injured or not. Then we have to acquire the data. So for example, I use one of these fancy sport watches. I record the heart rate, the velocity, maybe the day, maybe the amount of sleep. I must prepare the data. So as an output, I need one adjustable CSV file, which I tell precisely, okay, the last column is the user feeling, so the user has to manually type, I feel okay, and it will be the, sorry, and it will be the information to the algorithm that it must focus on this last column precisely, and the rest of all existing ones will gather and try to predict the function. Finally, I must train it. So as I told you earlier, I choose one of the existing algorithms. I divide the subset of data into, for example, 70% to 30%, and I test it. Is it working properly? So how this approach went with the disease detection with the help of Azure. Let's figure out. So first things first. Problem definition. So we touch the sector of educational health. We wish to detect all kinds of anomalies in endoscopic photos. And as a solution, maybe machine learning will help us to diagnose the problem. Let's see. So when we have this scratch, we try to generate some hypotheses. For example, by classifying endoscopic images using machine learning, one can build a system supporting the recognition of pathogens in the digestive system. Why supporting? This is very important because as the developers, you are responsible for the tool to deliver it to the client, and the client is responsible to use it. So we cannot say, I blame the AI program, it's his fault. No, in the 21st century, in the 2021 year, for now, there is no law which allows us to bring the responsibility to the program or the software development, whatever how smart it is. So it's always support. He cannot yet take the full responsible decisions with the all chain of subsequences yet. Okay, so why this kind of problem? So for myself, and maybe this will encourage any of you, I wanted to know a little bit deeper of deep learning, practice some machine learning on real-world application, and also I wanted to extend my knowledge about the Azure. Okay, so now research methodology, and let's go to the sweetest part of the experiment. So how it went actually. So first of all, I needed to obtain the endoscopy data, and this is very tricky part. In this particular example, I didn't do it on my own. So there is an open AI set, which any of you can use at your home. However, there are restrictions. So this project cannot be sold to the client because I didn't gather the data, I didn't get the license. As a researcher, I'm allowed to extend the knowledge of the IT world. However, it cannot be sold to the client because other researchers went to the hospital, asked the actual patients, gathered 8,000 cases. So this is like protected by law. But of course, it can be used to the home or student projects to extend your developer skills. If we already passed that step, so I have any fancy data set, let's try to categorize it. So in this case, the idea was to put it into 8 different categories. So for example, the polyps in the endoscopy images, or the cancer, or the healthy one, or stuff like that. I have no idea about the medicine, so I don't understand even those categories. Then the fancy stuff here is the using Azure Cognitive Services to learn the model. What is the difference? So in the regular approach, as told you, as a developer, for example, in Python, in the machine learning, I would do it step by step. So I don't know, approximately 300, 500, 1000 lines of code, and step by step all the machine learning process. And here, Azure Cognitive Service is the nice and the easy IDE available through the web, so we can create deep learning models just a few clicks. So I can put from the toolbox, this is my data, this is the output, and it just happens. And of course, we cannot neglect the model testing. So how it looks like, this is example images of the polyp in the endoscopy images. And as I said, 8 categories, 8,000 photos, so it gives us 1,000 training unique individual photo per set. To make the algorithm works, we need to manually divide those photos in the separate folders. And for the consistency, it's best to unify them. So all the photos are in the same size. If they are not, this is our responsibility to somehow reprocess it. And then we can go to the Custom Vision AO portal. Right now I have some internet problems, so it will not work. However, you just need to gather your Azure license portal. Then it's super simple. You just add the images. As I see you on the left, I create the categories which were externally prepared by the medical specialist. And after you upload everything, you just click fancy button train, and the only thing you need to do is decide for quick training or advanced training. And of course, you might be curious, why is it so easy? Why doesn't everyone do it? Because it costs money. So to train this model, I spent 50 euro. Maybe it's not a lot. However, if you think about the real world problems when I would have, I don't know, 2 million of such data, the cost grows rapidly. So it's always balance. Either I have quick fancy tool so I can quickly show to the client that it works and prove my data, and maybe other team in the same time can use the clean code and try to do it more regular way, so we have bigger control over the cost. However, Azure is very cool because after 15 hours using the already pre-trained models, so Azure has their own models trained of millions of images, and it only extended his set of knowledge on my images. I obtained the tool. This is also tool generated by Azure, so I didn't develop it. And take a look. I can either put the image URL here or drag and drop. And this is the recognition. So it says that on 96.8% this is polyp, and actually it is polyp. And what is most interesting, that the final results got better than the parallel team which did it in the Python code on their own. So one team used, I don't know, 2-3 months to create deep learning code in the Python and then obtain like 68%. And as you can see, the overall performance in the Azure was 97.6. So this is hilarious how good it is. Because what is also important, deep learning is very costly. So the team who was trying to learn it on the Python code has super fancy computers with 64 gigabytes of RAM, with the cutting edge graphic cards, and the learning process took like 36 hours. And Azure did it so quickly because he already had prepared, precompiled models. And also Azure as a cloud provider can in 1 second give you, I don't know, 100 computers and 100 GPU cards. So everything goes faster and faster. So if we take a look, we finally obtained the 3 results. So if model recognizes the photo, what is probability that the conclusion will be valid? 97.2. So it's very high. However, if we already from the properly recognized fields, how good coverage we have? 79%. So when you go into polyps, from the 1000 polyps, in final we found 79.4%. So this is still quite place for improvement. Of course, this is not 100%, however, still a lot. And the third result is just average of these two with some fancy modifications. So in total, it's called average performance. And as Azure say, this model is for 97.6% cool. So what I recommend you to do, if you have any idea, anything you like to do, for example, you love cars and you want to recognize them, you love the beers and you want to recognize the kind of ingredients which are inside, or whatever you like, try to gather some data, like photos, like the text description, like any other data, try to put it in the cloud and see what you can get. Because it might be the fire which will ignite you. Okay, I want to become the AI developer, and then you can start to build your own models, and then, of course, finally sell it to the client. This is everything for me. Thank you for your attention. If you have any questions.